Again, welcome everybody, and thank you for joining us on today's webinar, Instrumented for Safety, Simplify Compliance and Reduce Risk. I'm Allison Sterling, a Marketing Manager at Emerson Micro Motion, and I'm pleased to welcome you to the Emerson Flow Expert webinar series. Before we begin today, I'd like to take a moment to acquaint you with your webinar environment. On your screen, you should see a presentation window on the left side, a Q&A chat window in the upper right-hand corner, media player controls, and a resource box with related content that you can review and download during the event. You can resize, move, or minimize any of these windows during the event to fit your viewing preferences. At the bottom of your display, you should see a row of icons that give you some added capabilities, such as sharing this webinar via social channels or requesting a visit from one of our Flow experts. Throughout our presentation, we encourage you to interact with our speaker by typing in questions and comments in that chat panel. We'll answer questions during the event as well as after the presentation. We are also recording today's session, and we will make the link of the recording available 24 hours post-event via email. On today's webinar, we are lucky enough to have joining us Tanya Wyatt, our Global Chemical Industries Marketing Manager for Micro Motion. Tanya has been with Emerson for more than 15 years, working closely with our customers across multiple industries around the world to help improve their flow measurement and improve process efficiency. She has authored and presented numerous flow measurement papers at industry events. Before joining Emerson, Tanya has spent 3 years working in a chemical plant doing R&D. Welcome, Tanya.
Thank you, Allison, and thank you everyone for joining us today. We have a rather large group, and we really appreciate everyone taking time out of your schedule to join us. As you know, we're going to be talking about potential safety improvements today, and how I'd like to approach this is just talking about it from 2 different perspectives. One is that technologies you use can actually help you better understand your process. So that allows less human interaction and ultimately allows you to make better decisions about your process to help you maintain your safety. The second is that many technologies are offering advanced diagnostics that can reduce maintenance events, and they can also help with extending proof intervals and making safety instrumented systems, or SIS, compliance easier. So intuitively, you already know that there are a lot of reasons that you can use advanced instrumentation. Instrumentation can help you improve quality, throughput, and availability of your process, so that allows you to bring more product to market and increase your revenues. On the other hand, instrumentation can also help you eliminate or at least reduce your waste and rework. It can help you lower energy usage, reduce safety, environmental, and health costs, and reduce the need for maintenance. The focus today, of course, is on safety, but reducing maintenance can also reduce safety risks as well. Accidents are far more likely to occur outside of normal operations, so every time you have to shut down or restart your process, you're actually introducing safety risk. So with more online diagnostics that can extend or eliminate maintenance, these safety risks are reduced. So I realize a lot of you are here to learn more about true safety instrumented systems that follow IEC standards, and we'll definitely be discussing those applications later. However, I would like to start just by giving an example of how advanced technologies can actually provide more insight into your process. This is useful whether you're just using instruments in a basic process control application or if you're using them for safety systems. Here you can see a picture of a Coriolis flow meter, and I'm sure these are really familiar to a lot of you on the call. Coriolis meters are well known for providing accurate mass flow measurement. However, they also measure density of the process fluid, and they have built-in temperature measurement. Using the density and the temperature measurements, they can calculate and output other process variables like percent concentration or percent solids. The mass flow combined with density can also be used to output volumetric flow rates through the line. So as you can see, there are a lot of process variables that are available to you, and these are available regardless of which direction your material is flowing. So whether you're using your meter for intentionally bidirectional applications like loading and unloading, or if the flow changes directions unintentionally due to a failure of a valve or something of that nature, you have the visibility not only to the flow of the fluid, but you can also see how the fluid is behaving and see some of its properties. That data can be output from the Coriolis meter, and then you get a lot of information just around your process and what's going on, helping you to make more informed decisions. So how does this play into safety and why is it important? Well, I'd really like to share a story with you about how one of our customers uses Micro Motion Meters in his process to maintain safety. To give you just a little bit of background, this chemical company was originally using a fully compensated orifice plate to measure chlorine gas going into a gas phase reactor. Unfortunately, the differential pressure, or DP meter, that they were using wasn't accurate enough to properly control the chemistry of the reactor. At one point, the reactor actually went out of control, and it resulted in a backflow of acid through the chlorine gas feed system. There was absolutely no indication that this had happened, and a fire resulted. Unfortunately, the fire actually caused a fatality. So as you can imagine, this immediately drove the customer to carefully consider different alternative measuring technologies to help reduce risk and try to prevent something like this from ever happening again. After he weighed multiple options, they ended up choosing a 2-inch Micro Motion Elite Coriolis mass flow meter that not only was able to accurately measure the chlorine and help keep the reaction in control in the first place, but it could also tell them if the flow ever changed direction in the meter or if there was any kind of liquid in the line. So they used the density as a diagnostic in this situation. As shown in this quote, the customer really valued the process information that they got from the meter even more than the accuracy and the reliability that they got from the Micro Motion meter. Another benefit they saw from switching to Coriolis from the DP meters were significant reductions in potential leak points. With each of the DP meters that were in place before, they had 7 potential leak points with the impulse lines and different connections on the orifice meter. With the Coriolis meter, there were only 2 potential leak points, one at the inlet and one at the outlet process connection. Reducing leak points is really critical for chlorine gas and some other gases as well, but chlorine gas because of its inherent dangers. In fact, federal standards limit workers' exposure to concentrations of less than 1 part per million. And that's because 40 to 60 parts per million can produce lung injuries, and 430 parts per million usually result in death within 30 minutes. And just 1,000 ppm is fatal in just a few minutes. While leak testing is obviously done routinely and the risk is mitigated that way, any reduction in potential leak points is a benefit. If you want to learn more about this story, you can download the proven result from the Resource Center on your dashboard that Allison pointed out earlier. Unfortunately, though, accidents can and do occur, so safety instrumented systems in the safety life cycle are implemented to help you reduce the frequency and or the severity to minimize your overall risk. Like many other companies, I'm sure you implement safety instrumented systems to help reduce your risk. These safety instrumented systems focus on preventing accidents, not recovering from them after they occur. There are many safety standards like IEC 61508 and 61511 that you are probably already familiar with. While these are intended to be standards, they are compulsory in some locations. So just as a basic overview, there are 3 elements in a safety instrumented system: a sensor, a logic solver, and a final control element. As you know, the sensor is the part that collects information necessary to determine if an emergency situation exists. The purpose of these sensors is to measure process parameters like temperature, pressure, flow, and other parameters to determine if the equipment or the process is operating in a safe state. The logic solver is what decides what to do with the information from the sensor, and it sends a signal to the final control element or actuator to take an action to establish a safe state of operation. The SIS is designed to reduce the risk associated with the process. So it's recognized that the risk will never actually go to zero, but you can determine an acceptable risk level and design to that. IEC standards specify precise levels of safety and quantifiable proof of compliance. So once you've established appropriate safety integrity levels, or SILs, for your plant, we want to help you meet those levels in the most effective way possible. Emerson actually offers a lot of safety products. We offer the Delta V SIS logic solver and many final control element products that you can learn more about by clicking on the link in your resource center on the dashboard that is called Emerson SIS product website. And there you'll find a lot of information about our safety products, including the sensors that we'll talk about today, but the logic solvers and the final control elements as well. Our focus for the remainder of today's seminar will be on the flow sensors specifically. Okay, we've gone through quite a bit of introduction stuff here, so let's just take a moment to get some interaction with you all on the phone, make sure everyone's still out there, and really get some information about what type of safety instrument and systems you guys are currently using. So you should be seeing a question right now. If you can go ahead and submit your answers to that, whether you're using certified devices, proven in use, or prior use devices, or maybe some combination, or maybe you don't know, and that's okay too. So it looks like we have some questions or some answers coming in. We'll give just another moment or two for those to come in. Okay, I'm going to go ahead and close this now. Okay, it looks like there's a good combination of what you guys are using out there, but it looks like the majority are probably using mostly proven and use devices. Although if you combine the certified plus the mostly certified, that's a pretty good number too. So it looks like quite a variety out there. So at Emerson, we definitely have a combination of both prior use and certified devices, and we'll talk about both of these. I am going to start with the prior use devices and discuss them first. Emerson offers magnetic flow meters with the 8732E and the 8712E, as well as 8800 vortex meters for prior use applications. To make the documentation process easier for you for these devices, we actually have a hardware assessment that has been provided by Exida. The hardware assessment consists of a FMEDA, which is failure modes, effects, and diagnostic analysis, to help determine the fault behavior and the failure rates of your device. These are then used to calculate the safe failure fraction, or SFF, and the average probability of failure on demand, or PFD. This assessment actually provides the safety instrumentation engineer with the required failure data per IEC 61508 and 61511. All of this information can be found on our safety webpage. So you can go to www.rosemount.com/safety, or again, use the link in the Resource Center about our Emerson SIS products. These devices have been used in both SIL 1 and SIL 2 applications. So let's talk a little more specifically about the Rosemount mag meter. The Rosemount magnetic flow meters can be ideal for many chemical applications. They have a broad range of liner and electrode materials. They have built-in diagnostics, including grounding and wiring fault detection, process noise reduction, and smart meter verification, which checks the health of the device. Rosemount also offers the 8700M with industry-leading hazardous area certification. It has fully isolated electrodes that enable IA protection type, has glass headers for secondary containment, and industry-leading temperature codes for all approvals. As you probably know, one of the most common causes of flow measurement errors for magnetic flow meters is improper grounding. The grounding and wiring fault detection that is available on the Rosemount mag meters monitors the entire frequency spectrum to recognize if AC noise is affecting the flow reading and alert you if it is. Historically, another thing that has been tricky with mag meters is verifying their calibration. It typically involved removing the flow meter from the line or using extra equipment. Smart meter verification is a diagnostic that provides calibration verification without having to remove the meter from the line or using external equipment. Smart meter verification performs diagnostics that compare baseline values for coil signature, coil resistance, and electrode resistance to verify the meter's magnetic field strength is unchanged and undisturbed from the factory and the flow measurement is correct. Flurries can create noisy outputs, which result in valve actuation, so high levels of damping are common for slurry applications to take care of this issue. But damping equals control loop dead time. So damping actually makes the flow signal look stable, but the valve won't change position rapidly even when there are real flow rate changes, so that adds to your real process variability. Rosemount offers something called the High Process Noise Diagnostic and User Selectable Coil Drive, which provides maximum stability with minimum damping for these noisy slurry applications. Rosemount also offers an 8800 vortex meter that is used extensively for safety applications, and it has a lot of great attributes also. Some of the attributes that it has are reduced leak potential with a gasket-free design, meter verification that checks the electronics, and sensors that can be replaced without taking the meter out of service. The Rosemount vortex meter is also available as a dual vortex meter that basically eliminates the straight run needed for the second vortex meter, but it still provides two independent flow signals. These are great for safety applications. One signal can be used for basic process control system, or BPCS, and the other for the safety instrumented system, or SIS, or both can be used for the SIS to enable redundancy for higher SIL ratings. Rosemount also provides a quad vortex, which enables 2 out of 3 voting schemes for SIS, plus basic process control, or you can use it for 3 out of 4 voting. The quad vortex has 2 meter bodies, primary elements or shutter bars, and it has 4 independent sensors and 4 independent electronics. I'd actually like to share a story with you about a customer that used a quad vortex for their safety application. So this customer needed a 2 out of 3 voting for a safety instrumented system and required a 4th flow meter for regulatory flow control. A safety instrumented system was installed for the personnel protection to almost eliminate the risk of 2-phase backflow from the reactors back to the feed system. 2 out of 3 voting logic greatly reduces spurious trip risk and provides robust SIS coverage. In addition, the 2 out of 3 configuration greatly simplifies online critical alarm testing. They really wanted to use vortex meters for the application because the alternative DP meters required a lot of heat tracing of the impulse lines. They had more potential leak points, and they had a potential for impulse line freezing and plugging. And they also provided less rangeability than the application required for this particular application. The quad vortex would have been ideal for the application and would have provided all 4 measurement points. However, at the time, the vortex meters didn't have IEC 61508 certification, so they ended up installing the quad vortex to get some operational data so that they could provide documentation to later use the devices as IEC 61511 proven in use. But they also installed some traditional DP meters downstream of the vortex meters, and this was to provide redundancy and to make sure that they complied with SIS until the sufficient testing and usage documentation could be created for them to just solely use the quad vortex. During the winter, it got really cold, and the impulse lines of both of the proven and used DP transmitters froze. Each DP meter was installed initially to back up the quad vortex, but in the end, the quad vortex proved to be more reliable than the DP flow measurement because of the reduced failure modes. Without the quad vortex, the customer would have experienced a spurious trip of their process unit, resulting in costly downtime. So they have been continuing to collect information and use the quad vortex as their primary safety system. So we've talked a lot about our prior use products. Let's now talk about some of the Emerson instruments for flow that are certified devices per IEC 61508. So Emerson offers Micro Motion Coriolis meters with the model 1700, 2700, or 5700 transmitter for use in safety instrumented systems. These devices are all available as certified devices per IEC 61508, and they can also be used as prior use devices. And this is so the prior use devices, is applicable to the 1700 and 2700 devices. They're all certified as SIL 3 capable, and we also have additional products that have been used as prior use devices too that I don't have listed here, but other devices have also been used as prior use. In addition to the improved process information and reduced leak points, potential leak points, I wanted to briefly talk about how diagnostics have improved over time and have resulted in additional safety improvements. So as you're probably quite aware, in any safety instrumented system, safety scores and SILs, or safety integrity levels, are highly impacted by diagnostic capabilities. As instruments are developed with more and more diagnostics, more of the dangerous faults of the device can be detected. This means that dangerous undetected, or DU, failures will be lower and your overall safe failure fraction, or SFF, will improve. This results in improving the overall score of the device and can often mean that a device will be rated for a higher safety integrity level. Safety instrumented systems have to go through periodic proof tests to make sure that they are still functioning correctly and to reveal potential dangerous undetected failures. Some advanced diagnostics can make the proof testing process a lot easier than traditional calibration tests. So I'm not going to get into a lot of the math here, but let's take a quick look at how to calculate safe failure fraction and how diagnostics can help improve that score. The total failures in time, or FITs, are made up of both safe and dangerous failures. For a safety application, we're more concerned about the dangerous failures. The safe failures, whether they are detected or can't be detected, are defined as those that would result in a safe situation even in the event of a failure. The dangerous failures, or failures that have the potential to put the safety instrumented system into a hazardous or fail to function state, are split into two different categories. Those are the detected ones and the undetected failures. Detected dangerous failures are ones that have diagnostic coverage so that you would be notified of the failure and be able to take the appropriate corrective action to allow for a safe shutdown of the process. So the safe failure fraction is the amount of failures that are either safe or dangerous and detected. A high integrity design for instrumentation will have a high SFF. Proof testing is then used to try to look for those dangerous undetected failures. So let's take a look at some of the safety scores for the Micro Motion Coriolis meters. As you can see, all of the SFFs are in the 90+% range. And just for reference, some other Coriolis meters may be in the high 80s or the very low 90s from numbers that we've seen. The Model 2700 has good SFF values, but the Model 5700 is even better. It's best in class, in fact, with SFF values in the mid to high 90% range. So you can see here it's like in the 96 to 97% range. The Model 5700 has incorporated a new diagnostic on the SIS version that allows you to continuously monitor the milliamp output of the device with a built-in milliamp input, and this is what has contributed to that higher SFF number. By comparing the expected output with the input value, the meter is able to reduce some of the potential undetected failure methods, and the SFF is improved. More information about this can actually be found in our safety manual on the Model 5700 web page, and a link to that web page is actually located in your resource center. And actually, this is a good time to point out that if you have any questions or anything that is not covered in the resource center, or you would like more of a personal consultation, you're always welcome to use that Contact Me widget too, and just let us know your information and we will follow up with you for sure. So in addition to the milliamp output diagnostic, our latest transmitter, the Model 5700, also has a lot of other advanced diagnostics like smart meter verification and a new diagnostic called zero verification that makes it really easy to capture a great zero, and that helps provide more accurate measurement in high turndown applications. So those are applications maybe like low pressure gas or high viscosity fluids that require a lot of additional turndown. The Model 5700 also has automatic data logging that provides valuable historical information to help with troubleshooting of the meter or the process. So that data logging takes place automatically, and you can download information for 30 days or even several years from the transmitter and be able to look at your process history. The transmitter was designed around completely improving the user experience, and every feature can be accessed from the local interface. Configuration files and upgrades and data logging are all conveniently available using a USB type interface, so you can transfer those using just a normal thumb drive. For more details, please feel free to use the Contact Me widget and request additional information, or again, you can visit the 5700 web page, which is in your resource center. So before we continue, I'd actually like to get a little bit more information from you guys. And just out of curiosity, I'm wondering how many of you have used advanced diagnostics to actually extend your foolproof intervals for instrumentation in your SIS applications. And we'll talk a little bit more about some of these options, but I'm just curious to see how many people are using it right now. Okay, thank you. Sorry about that pause there, but it looks like we have a lot of answers here. And it looks like many of you are not using any kind of advanced diagnostics to extend your foolproof intervals. But a few of you are, and so about a quarter of the population here is using it. So I'm really happy to see that some of you are using those advanced diagnostics to extend your proof test intervals. And I'd like to talk here just about an example of an advanced diagnostic that can do this, and that's the smart meter verification diagnostic that Emerson uses to quickly check the health of a Coriolis meter from Micro Motion. Each meter is actually individually fingerprinted in the factory using multiple test tones. So we send frequencies to the meter, and we listen for the response. So one is at the natural frequency of the system, and then we send 2 at higher frequencies and 2 actually at lower frequencies. The response to each of these 5 frequencies is used to characterize the meter. So when the meter is installed in the field later, a simple push of the button allows the same test to be performed and the results to be compared to the fingerprint. Within minutes, without stopping the flow, without exposing personnel to the process, or removing any flanges, the health of the meter can be tested. This has significant safety benefits even when it isn't installed in an official SIS. However, when used in conjunction with SIS, this diagnostic can actually be used to improve the proof testing. And so what I mean by that is, over time, the probability of failure on demand increases if you're not testing anything. And so periodic proof testing is required in SIS to maintain an average probability of failure on demand. So as shown in the first graph on the left, you can have an instrument like a flow meter that has a proof test interval of every 3 years to maintain a certain average PFD. This means that every 3 years the meter has to be proof tested. If you choose to do a full proof test more often, like in the graph on the right, then you can reduce that probability of failure on demand and potentially get a higher SIL rating. This example shows that doing the full proof test every 1.5 years reduces the average probability of failure on demand. And I do want to make a note that these time intervals are examples only, and actual proof test intervals are going to vary depending on your SIS requirements and are going to be calculated depending on your SIL levels and other variables that you put in there. But for this example, let's say that a full proof test is a calibration. So a full meter calibration may require shutting down the process and removing the meter from service and sending it to a calibration facility. There are definitely inherent safety risks involved with pulling the meter from the line and with restarting the process. So doing a lot more proof tests generally is not the preferred answer. So in order to reduce the full proof test interval while maintaining the same probability of failure on demand, many partial proof tests are used. So you guys might be familiar with this when you think about partial valve stroking. I think that's probably the most common example. But basically, as you see in the graph on the right, even though the partial proof tests don't bring the equipment back to the original PFD number, it drops it enough to extend the interval of the required full proof test and still maintain the same average PFD. So the micromotion model 1700, 2700, and 5700 all take advantage of the smart meter verification diagnostic in helping with partial proof testing and extending the full proof test intervals or full calibration. So the table here shows the results of the DU coverage of the various transmitters with different types of proof testing. And as you can see, the first 2 proof test options allow you to leave the meter in the line, so you have minimal disruption. And then the third proof test is a full proof test where you pull the meter from the line. The first proof test option checks the milliamp output, the alarms, and the configuration, and covers about half of the undetected failures. You might notice actually on the 5700 transmitter has a lower DU failure detection coverage in this method than the 1700 or 2700. But I do want you to keep in mind that this is because it has a higher SFF, and so there are actually fewer DU failures in the first place. So they both are good tests for the proof test 1, but it's going to cover only about half of your dangerous undetected faults. The best option, of course, to detect your DU failures is by removing the meter from the line and calibrating it against a primary standard. And this will cover about 99% of the DUs and is the full proof test. However, using smart meter verification is a really good option because it allows you to get 91% of that coverage without requiring a wet calibration. This is really exciting because it can extend the amount of time between full proof test requirements and reduce the need to shut down the process reducing the safety risks inherent in performing these non-routine operations. So at this time, I'd kind of like to begin wrapping up. I'd like to remind you that advanced measurement technologies offer really significant opportunities for improving safety, whether it's just through improved knowledge of the process itself that allows for advanced notification of any kind of potential dangers and allows you to make better choices, or whether you're looking at some of the advanced diagnostics that are offered today that can actually help extend proof testing intervals, reduce your probability of failure on demand, or reduce traditional maintenance and shutdown events. So I'd like to thank you for attending this webinar. We're going to have time for some questions now, and it looks like a few have already came in. Please remember that if we don't have time to answer your questions, we will try to follow up with you with an email. You can also at any time use your Contact Me form to request a follow-up visit or send an email to me directly. And I'm also honored right now to have some guests here with me today with a lot more experience in the functional safety area than I have to help answer some questions. So with me today I have Tom O'Banion. He is our Director of Industry Differentiation. And Ezra Sobel, he is an engineer who has a special focus on safety applications and ratings. They both have approximately 10 years of experience in this area, and so they should be able to help answer any questions that you guys might have. I'm going to turn it over to Allison now, and she's going to help facilitate this Q&A session.
Well, thank you again, Tanya, very much for this great presentation and all this great information. As Tanya's already mentioned, we're going to now open it up for questions. We've already got some sitting in the queue, so please start sending those through and use that chat panel to send those through. And as Tanya mentioned, if we don't get to them, we will certainly follow up afterwards. And both Tom and Ezra are thrilled to help you answer any of your questions. So I'll turn it back over to them and let them start answering. Thank you, guys.
Great. Good afternoon to most of you. Thanks again for these great questions. I think in order as they've shown up in our screen anyway, Hector Rodriguez of Olin asked the question, does a smart meter verification come with the transmitter when you purchase, or is it an extra option? It's actually an extra software option. The list price is $17.50. If you decide that you are interested after you've bought and installed the meter, as long as you have the right transmitter core processor, that can actually be upgraded in the field and turned on by a service technician.
Yeah, and just to add to that, smart meter verification, again, is offered on our magnetic flow meters and our Coriolis meters, and both of them have some upgrade options in the future. If you ordered one without it, definitely talk to us and we can see if that option is available for you. So one of the questions that was asked also is the SIS version of the transmitter the same as the non-SIS version? And so I think I'm going to let Ezra answer this question.
So the hardware is exactly the same. Once again, on the 1700, 2700, there is absolutely no difference between the SIS version and the non-SIS version. The 5700 version, it's the exact same hardware, but there is a special license feature that you need to enable the SIS feature, and which enables extra diagnostics and the use of the milliamp feedback.
Okay. So again, if you have an SIS requirement, it's good to let us know up front, especially on the model 5700, because then we can make sure that you do get that license feature. So it looks like we also had a question about how does data logging improve SIL and improve SF? And
it doesn't. So the data logging is really just a way that you can troubleshoot your process, troubleshoot your transmitter, the flow meter within the process. Is it a problem? Is it a process problem? Is it a transmitter problem? Very often data isn't collected, and an event happens and nobody knows what exactly happened. With the data logging, we have all the information that the meter sees, and so then we can actually look back in time what the transmitter actually saw, and we can then plot it out after the fact and do some troubleshooting that way. But it doesn't help the safety function at all.
Yeah, that was a good clarifying question. Looks like there's another question about what SIL rating is the actual transmitter itself.
So the Micro Motion transmitters are SIL 2 capable in a single use, so a single transmitter. They're SIL 3 capable when you use redundant meters, so in a 1 out of 2 scheme, a 2 out of 2, or a 2 out of 3 type scheme. I'm not certain about the Rosemount meters. I would assume it's similar.
Yeah, those are typically used in SIL 1 or SIL 2 applications. So, good question. Looks like...
question on the quad vortex.
How many flow elements were used before installing the quad vortex for this application? My understanding, and I wasn't completely tied in on this particular application, but my understanding was that they initially had 4 DP meters planned to be put in place, and then they ended up putting in the quad vortex with 2 backup DP meters for the application.
Alan Erickson of KMPS has a question about 190 proof ethanol. We can correlate quite accurately, Alan. We measure density. We can either build in the isotherms in our transmitter, or you could do it in a DCS or PLC and convert that density measurement along with our temperature measurement back to proof. So you could use the Coriolis meter as a proof meter to help you in your process control, and I'm assuming that's SIS related here.
Okay. Looks like there was a question about some typical applications for SIS, where Coriolis would be the flow technology of choice. And we have seen kind of some fast reaction type applications like feedstocks, catalysts, etc. Combustion fuel is a good candidate, and we've seen that a lot. EO and PO reactors are ones that we've seen, and you know, there are a number of different applications, but those are some of the typical ones that we've seen Coriolis being used for SIS. Looks like we have a question about, seems like smart meter verification could actually eliminate wet proof testing altogether, with a question mark after it. So, comments, Ezra?
No, because with the smart meter verification, as part of your proof test, we're only getting a 92%, 91% coverage. So there's still some things where we're not getting everything on, so you still have to do a full calibration if you want to have the full coverage.
But it would certainly buy you a couple of extra years, potentially.
Yeah, it improves it quite a bit, but it doesn't eliminate the need for it entirely.
Okay. Tom, do you want to grab that one about I'm at a small company?
Wait.
And we're not SIS experts. Do you have any CSFEs that can help out with that?
Emerson has quite a network around the globe. I think the number is around 30, and they're available for fee-based consulting. Certainly if it's relatively simple question, an hour phone call consult is always available, and that's for free. But real nice network of certified experts to help you out if this is not your full-time job, or you have questions to get the loop design right, or the proof testing, et cetera. Many of them, prior to working for Emerson, were actually users themselves, so they were safety designers in a former life. So certified as well as lots of practical experience.
So if you are interested in that, you can use the Contact Me form, or they do have a website. It's www.emersonprocess.com/consulting services. And then there's a quick link to SIS services. So a number of different consulting services are listed on there, but SIS specifically as well. Somebody asked if smart meter verification is automatically run every 3 months, how long will it store the data on the transmitter? So, and how is the data retrieved? So there are two different answers to this. On the 1700 and 2700, we store the last 20 smart meter verification results, and you can retrieve them using software like ProLink 3 or AMS, but there are ways to retrieve those results. On the model 5700, it's basically going to be storing that smart meter verification results almost infinitely, I mean, for several years. So, and you can retrieve that information similarly, but you can also retrieve it using the USB option that we mentioned earlier. So hopefully that answered that question.
The question related to documentation on DCS, I'm assuming that means Delta V SIS, and the Emerson website has a very nice SIS area, so we'll make sure that we publish the link to that.
And then related to that is diagnostic coverage for smart meter verification for the 8700 meter. That's the Rosemount meter. So Rosemount has a website where they have all their documentation, and so we'll need to add that link to
get to those scores. Apologize, we don't know those off the top.
Yeah, and they do have a full hardware assessment on there, and I don't remember the numbers for the smart meter verification off the top of my head, but we can follow up on that answer as well.
So from Jeff Neese asking, how is dangerous diagnostic information relayed to shut down the process? So all of these transmitters, the process variable is reported over the milliamp output. So if a fault is detected, the milliamp will be programmed to go high or low, to a high fault state or a low fault state, and that is user selectable. So you can, when you set it up, you can set it up to go high or set it up to go low. There are also undetected failure states where it will fail high or fail low, go out of scale high, essentially to the rail or to zero. And so you should set up your process to detect that if it's out of scale high or low, that's a shutdown signal.
Okay. So somebody asked, are the DU coverage percentages covered by TUV or Exida?
We have used Exida to evaluate our products and our processes. So our FMEDAs and our certificates are all done by Exida.
So mind opens up.
Okay.
Excellent, two counts, but there's no partial.
So then we have a question, is the data logging stored in non-volatile memory?
So RF.
And I believe that is stored in non-volatile memory. Am I correct?
The data, the 5700 has a SD card, memory card, like you might find on your phone. And so that is, all the data logging is stored to that SD card. So it is non-volatile.
Okay.
So question regarding details of Exeda's Excellencia calculation about partial test. We'll have to get back with you on that note. We have a very close relationship with Exeda. Bill Goebel and his team have done a lot of work with various Emerson business units, so I'm sure they would be amenable to modifying that tool to reflect S&V. And yes, we can provide all those numbers.
So this question, I think, is for you, Ezra. Not all SIL verification, like Excellencia packages, let the user take credit for diagnostic coverage. What does ISA recommend?
I don't know what ISA recommends, and that also seems to actually go back to Tom's last answer.
Yeah, ISA SP84 basically mimicked what's in the IEC standards. The whole IEC effort was to try to harmonize global approach to safety. So ISA is going to follow whatever the IEC prescribes.
But so the silver, that's the Excellencia package. That's once again Exeda's tool. So, and I'm not sure exactly how they've implemented the various calculations in the tool. So
it's accepted by IEC, so I'm assuming it's just a matter of catching the tool up with current diagnostic offerings. It's a question about proof test.
So it says, what is the proof test interval to maintain the flow meter at SIL2, and what testing is required? And so I run up against this all the time. So the flow meter itself is SIL2 or SIL3 or SIL1 capable. It is the safety instrumented function, the whole function, which is rated to be SIL2. So you need to maintain the whole function at SIL2, and that's your flow meter, or your meter, your logic solver, and your final control element. And if you have multiple meters, multiple logic solvers, multiple elements, it could be a whole lot of things. And so the calculations, you need to take into all the components in the system. And so if you have a relatively simple system, it could be a relatively simple calculation. But if you have many elements within the system, it gets complicated very quickly. And you have to, it's the sum, essentially, of the sensors, logic solvers, and control elements. So you can't just say, for the flow sensor, do it every year and you'll maintain it, because your sensor only takes a percentage of your total budget. And you need to take into account all of the elements that are within your system. It's not a very easy answer.
I've been told for a common SIL2 application, generally, you would do the proof test once a year. But it's very dependent on the details.
Right.
As you just described.
And that's if you are not doing the smart meter verification to extend that?
Right.
Correct. Okay.
So you could push it out to probably, I think if you do the math, probably 3 or 4 years would be achievable.
But again, you'd have to do the math.
Yeah, please do the math.
Yeah. Somebody said, can you really calibrate a micromotion meter or only verify a volumetric flow versus another technology like weighing? I can zero a meter, but this is different than calibration, right? So.
Yeah, what you're really after, the metrologists worry really about at least 3 things. One is meter zero, so you're doing that now. You've got to have some way of checking the span factor, and that's really what meter verification does, along with checking the zero. But metrologists also worry about is the configuration of the outputs correct? So they're looking for any potential sources of fraud or inaccuracy in there. And as well, a lot of people would add in to make sure that the signal is being interpreted properly in the DCS or PLC. So zero is part of it, but you need to do more to verify the integrity of the complete measurement and the signal as it's received.
And then I guess the other part of that question is about verifying against a volumetric flow rate or another technology like weighing. And so I guess like when we initially calibrate micro motion meters, we do that using a system. We have primary systems that actually use weighing, but most of our sensors that are sent out to our customers are done using a transfer standard method, which basically uses multiple highly calibrated flow meters and then uses that as kind of a bank of reference meters and does a comparison testing to do the calibration. So hopefully that answers your question, but
it's a mass flow calibration either way, and we also have a density calibration. And then the volume, if you need volume flow, volume is calculated from mass and density. But at the factory, we're calibrating mass and density, not volume.
Yeah, and it is common for some applications to do proving with ball provers or something like that, where they are being compared to volumetric measurements. But so that's a really good question, and it can get complicated. So somebody asked about, do all SIS transmitters have an inherent data logging option, or is that an additional option that can be purchased, similar to the Micro Motion 5700 with the SIS embedded historian? So the historian, the data logging feature, is actually fairly exclusive to the Model 5700. It is an option that is standard on the Model 5700.
It needs to be licensed, so.
I don't think so.
That's right. No, they
No.
all come with it.
So it's automatic on the Model 5700. So.
Because there's a checkbox when you go in the licensing key feature histogram.
We don't sell it.
It's default now.
Okay. It actually looks like our questions have pretty much slowed down, and we are right at the top of the hour as well.
Perfect timing, just the top of the hour. So if you do think of any additional questions, or we haven't got to your question, we do have a couple that I think we still haven't answered. Please don't hesitate to contact us via the contact button, and we will get back to you. Thank you again for joining us today. As a reminder, we will be sending out a recording of the webinar tomorrow, along with links to all the additional resources. So if you do think of those additional questions, you can also respond back to that email, and we'll get back to you. On behalf of our guests, Tanya Wyatt, as well as Ezra and Tom and everyone here at Micro Motion, we thank you again for joining us today on the webinar and taking the time to view the presentation and ask all your great questions. We hope you all have a great day, and until next time, thank you again. Bye-bye.
Thanks, everyone.
Thanks.
Bye.